Good morning, class. Today we are going to discuss about the topics alkenes and alkynes. This will be the last topic of the organic chemistry. Before this, we discuss about alkenes, okay, and that is saturated hydrocarbon having a single bond. Now today we'll discuss about unsaturated hydrocarbon, alkenes having a double bond and alkynes having a triple bond. Now let us begin with the nomenclature of alkenes. The general formula is CnH2n, and with the first n equals to 1, alkene is not possible because it should have two carbon atoms, so we put the value of n equals to 2. When you put n equals to 2, it becomes C2H2 into 2, that is C2H4. And C2H4, since there is two carbon atom, the name is ethene. Why Ene? Ene we have written because it has a double bond. For single bond Ane, for triple bond Yne, okay, like that. So the structure is this one, carbon having a double bond and 4 hydrogen, and in the condensed form we can write like this: C with 2 hydrogen and C with 2 hydrogen. This is common name is ethylene. Similarly, when we put n equals to 3, we get C3H6. The name of the compound is propene, and if you draw the structure formula, it will be like this. Similarly, butene, C4H8. This is the structural formula, the condensed formula, and IPAC name butene. Similarly, if you have got 5, then it is C5H10. It will look like this, and this will be pentene, and the structure is like this. Now, in alkenes, we mainly focus on this compound, ethylene or ethene, where you have got a carbon-carbon double bond, and each carbon is attached to 2 hydrogen atom. Over here the bond angle is 120 degree. Okay, now preparation of ethene. First preparation is dehydration of ethyl alcohol. We can prepare ethene by dehydrating ethyl alcohol. So ethyl alcohol, when treated with sulfuric acid, it will form ethyl hydrogen sulfate and water, and this ethyl hydrogen sulfate in excess of sulfuric acid and at temperature of 170 degrees Celsius, it will form ethene. Okay, or you can simply write, instead of this two equation, you can simply write this equation: ethyl alcohol C2H5OH in presence of constant sulfuric acid and 170 degrees Celsius, it will form ethene CTH4 plus water. Next, dehydrohalogenation. This is the second method of preparation of ethene. In dehydrohalogenation, what will happen? We'll have got an alkyl halide, that is ethyl chloride, is treated with alcoholic KOH solution. So what will happen? Because of this alcoholic KOH solution, it will remove Cl and 1 hydrogen from here, and they will form a double bond between them, C2H4 plus KCl plus water. Similarly, if you have got ethyl bromide, it will form C2H4, and instead of KCl you will have potassium bromide and water. Ethyl iodide in alcoholic KOH solution will form ethene, potassium iodide and water. This reaction is known as dehydrohalogenation because there is a removal of hydrogen and halogenation and hydrogen. Next, uses of ethene. Ethene is used in making polyethylene. It is used in ripening of fruits. It is used for producing oxyacetylene flame, which is used for cutting and welding of metals. It is used in the manufacture of synthetic chemicals. Okay, it is used in the manufacture of so these are the few uses of ethene. Next, we have got ethine. Okay, alkynes having a triple bond. The general formula is CnH2n minus 2, and if we use n equals to 2, it will become CnH2 into 2, that will 4 minus 2, that will be C2H2, and since we have got 2 carbon atom, it is ethine, and the structure is like this. Okay, having a triple bond between the 2 carbon atom, and the condense is this one. Similarly, if you have got n equals to 3, it is C3H4 propyne, the structural formula, condense formula. Then if you have got C4, then it becomes butane, structural formula, condense formula. C5 ipracium pentyne, structural formula, condense formula. This we have already seen in our previous classes. Preparation of acetylene. Okay, now acetylene can be prepared by reacting water with calcium carbide. Okay, this is the arrangement that we need to do. This is also the lab preparation of acetylene. Arrange the apparatus as shown in figure. Okay, so this is a, we can say, a conical flask. In this we have attached a thistle funnel, and this is attached with the cork, and it is passed through these water solutions. Okay, now let us see. Take a few pieces of calcium carbide, okay, in a conical flask. So in this conical flask you take a piece of calcium carbide and add a few drops of water through the thistle funnel. So after that, through this thistle funnel you need to add water. Okay, so what will happen? Calcium carbide reacts with water to form calcium hydroxide and acetylene gas. Okay, so calcium carbide reacts with water to produce colorless gas with ether like odor, ethylene, acetylene gas. The reaction is exothermic, that means heat is produced. So this reaction takes place. Now this acetylene is passed through this tube, and it is collected by the gas is collected by the downward displacement of water, since it is insoluble in water. So acetylene gas is collected over here. Next, we can also prepare acetylene from 1,2-dibromoethene. So when 1,2-dibromoethane or ethylene dibromide is boiled with alcoholic potassium hydroxide, ethine is formed. So when you have got this 1,2-dibromoethane and treat with alcoholic KOH, what will happen? It will remove HBr from here and HBr from here, and it will form a triple bond like this, ethine and potassium bromide and water. Next, uses of acetylene. It is used, number one, for oxyacetylene welding at very high temperature. These temperatures are obtained when ethane bonds in oxygen. And number two, it is used as an illuminant in oxyacetylene lamp. Number three, it is used for artificial ripening and preservation of fruits. Also for the manufacture of synthetic products like polymers, artificial rubber, and oxalic acid, etc. It is used for the manufacture of important organic compounds like acetaldehyde, acetic acid, plastic, and rubber. These are the few uses. Now to this assignment in question number 1, how is ethene prepared by A. Dehydrohalogenation reaction, B. Dehydration reaction? So you need to write equations, give equations, and name the products formed. Question number 2 is write the names and formula of the products formed in each case below. A. C2H4, this is ethene, reacts with chlorine, what it will form. Next, C2HBr, that is ethyl bromide, reacts with alcoholic KOH, what it is going to form, and name the product as well. Question number 3, give the method of preparation of ethine by 1,2-dibromoethane. How will prepare ethine or acetylene from 1,2-dibromoethane. And question number 4, give balance equation for the following conversions: calcium carbide to ethine. So how we can convert calcium carbide to ethine? So you need to write on the balance equation. So complete this equation and send it in my mail.